Hi again. Here's a quick overview of some questions that might help you in your next assessment task. I start with sine 82 degrees. I can enter that into a scientific calculator as sine 82 and press the equals button. Or if you've got something like an iPhone or that, you might have to put in the 82 degrees and then press the sine button. Either way, I get an answer of 0.99, and I have 0.2 on my calculator, so I'm going to round it down to 0, and that's 3 decimal places. Similarly, finding out the tangent of an angle, put that in my calculator, which I've just done, and I get 0.42, and I get 4, so again I'm going to round down and leave it as 4, so I don't need that last bit. That's much better, and that again is 3 decimal places. So if you can do that, it's a good start. Okay, here's our second question. In this one you need to find theta. So obviously if I want to know what theta is, I need the inverse of theta, which is cos to the minus 1, anti-cos, arc, actually not arc cos. And here we go, I've done this one and I get 79.630 degrees. I'm going to leave that at 63 degrees. That's to 2 decimal places. Similarly, for tan theta, I'm going to use the arctan, anti-tan. Which is 39, I get 0.351. I'll leave that second one as a 5 because the next number was under 5. That again is to 2 decimal places. And we're done. Okay, finally we get to some thinking. I have to find the unknown length, correct 2 decimal places. Showing my steps now. I know that y is the hypotenuse because it's across from the right angle. And then I look at my angle of interest and I can see that that other one is opposite. So I have my opposite is 14 and my hypotenuse is the unknown. And from your SOHCAHTOA, I hope you can see that sine theta is opposite over hypotenuse. It's 40.5 degrees. 14 over y. Have a different colour, so you know that I want to get this unknown over here, but I also then want to get that sine over with the rest of the numbers that I can work out. So I'm going to have y equals 14 over sine 40.5 degrees. And some people have asked me, and if the unknown's on the bottom in this type of question, you'll always swap them, whereas if the unknown's on the top, you'll just times across by the number. So if we do that on our calculators, hopefully you get 21.56 degrees, and that's to 2 decimal places as asked for in the question. Okay, similarly to the last one, I'm going to label my triangle, and I have a hypotenuse across from the right angle. And if I look at my angle of interest, this time I have the adjacent, so I'm going to write that down. My adjacent is 14, my hypotenuse is y. So I think this time from SOHCAHTOA, S-O-H-C-A-H, I think I want C-A-H as cos. So cos 38.5 degrees equals adjacent over hypotenuse, which is 14 over y. And again, the same as before, I really want to get that y across, but I need all the numbers over on the other side. That doesn't make sense. You can always ask me, but I think you'll be pretty right. So that leaves me with y equals 14 over cos 38.5 degrees. And by my estimates, that's 17.89. I didn't have the units, but that's 2 decimal places. And there you have it. Okay, next up, a couple of questions to find the unknown angle. You're stuck with me this far, you're doing okay. So looking at this diagram, I've got my angle of interest, and I can label my opposite and my adjacent. And obviously from my SOHCAHTOA, I suppose I'll write them down first. For my opposite is 14 and my adjacent is 12. Getting a little bit ahead of myself. SOHCAHTOA, tan is opposite over adjacent. So I can go tan theta equals opposite over adjacent, which is 14 over 12. Theta is the anti-tan of 14 over 12. Now if I do that on my calculator, I get about 49.4 degrees. It's good to have the degree symbol there because that's what it is. And we're done. And here we are for another problem. Curiously, these look very similar. Of my angle of interest, I have, what's it called, the opposite and the adjacent. So this time I'll write them first. Opposite is 11, adjacent is 13. From my SOHCAHTOA, tan is opposite over adjacent. Tan theta equals 11 over 13. Okay, look at the last one if you're not sure why I put those numbers there. Theta is the anti-tan of 11 over 13, which is hopefully 40.2 degrees. And we're done, and I think I'll take a break and then come up with some questions where I have to draw the triangles.